The NC Lab 2020 webinar series is funded through a grant from the Institute for Museum and Library Services and provided to the Nevada State Library, Archives, and Public Records System. The topic of webinar 2 is Fundamentals of Computer Programming and Karel Programming Unit 1.
This webinar is on the first unit of Karel, and we're focusing on adult learners, although this is useful for any level of learner. I thought it might be useful for people to understand why playing what looks like a little kid's game is really going to help them build some programming skills. And even with younger children, it doesn't hurt for them to learn the real concepts and real language of the concepts. I can think of an example when we started teaching Common Core math at school. Even the kindergartners learned what it meant to decompose a number. Those are big words, decompose. But not only did they learn it, but they understood what it meant. And so starting them off with the right language, I think helps them build what is sometimes known as metacognition, is thinking about your thinking or understanding how you think about something. And building some correct terminology. So I made one overview document for the whole course, and I broke it down into what you learn when you're learning Karel. And you'll see these terms, computational thinking, and really what it means is thinking like a computer. So we know how to think like humans, or we think we know how to think like humans anyway. But we mostly don't understand when we first start out how a computer thinks. So I bring up a couple of ideas, high level versus low level programming. High level is very much closer to how we think as humans, because what we're doing with the computer is we're taking tasks or problems or goals in human terms and figuring out how to make a machine produce a result. So programs that function at high levels or more human-like are referred to as high-level programming languages. Python is a high-level language, and most languages that people program in these days are high-level language. Then within the machine is basically throwing switches. And so languages that program the machine are referred to as low-level programs. You don't see very many people working in this area because there aren't that many people who are working directly with the machine itself. So high level, that's a program and it's independent of the machine it runs on. And then low level, it's very much making that machine do what you want it to do. So whether you're learning Karel to go into high-level programming or low-level programming, a lot of the concepts are going to be the same. But if you hear those terms, that's what they mean. Then we want to see what writes a good program. So I put up this little quote. And this came out of a meeting that we had with the head of a very large programming team at a major data analytics company. And his comment was 90% of programming is done on the whiteboard. In other words, the more you think in advance about what you're going to do, the better. And actually writing the code is secondary to figuring out how to solve the problem through writing a program. So that starts off by setting clear goals and objectives. My goodness, that sounds like what we should be doing in all our life. But in computer programs, it's even more important because the machine will only do exactly what you tell it to do, and it will do exactly what you tell it to do. In other words, it might do some stuff that you didn't want. Now, programs these days can handle some pretty vague requests, but it's just because they're very, very sophisticated. So, we're going to start simple. Once you set those objectives, then you have to go about figuring out how you're going to meet those objectives and solve problems. And you usually want to look at multiple ways, because sometimes you might think of something that looks obvious and it turns out it just doesn't work very well. So you have to be a bit flexible in how you approach problem solving and make sure that you have more than one approach, and also that you know how to break down
a big problem into little problems.
So that gets to something that we call algorithmic thinking. Now that you've kind of figured out how you're going to solve it, then you're writing some very specific processes. And again, you can do this in normal language. You can write it out before you turn it into a line of code. So the example I give here, which is from Unit 1, is that if you could say, Carol will repeat the following steps 10 times, move one step forward. And then you're going to write the repeat loop. So algorithmic thinking is we're going to express how we're going to write these procedures. And after a while, you can even name them. You know, there are certain algorithms that we use in Karel, like the wall algorithm number 1. And once you know what it is, you know what that means, and you can just call it up. You're building on your experience and the experience of other programmers. And then the next part you have to really watch out for is that everything you do is logical. So the computer is pure logic. It's just making millions of these yes or no decisions. But even at the high end, we want to make sure our logic looks good. We're making decisions. We have a sequence. If there are dead ends or there are breaks in the chain, the program's simply going to fail. So one thing that Dr. Solon has really emphasized in Karel is that you're going to write clean, elegant code. It's kind of like learning piano lessons. If you learn good technique to begin with, then it'll serve you all your life. If you learn poor technique to begin with, then you might have to start all over again. Syntax, that's just grammar. So, and all the conventions of grammar work in programming languages that we're familiar with: spelling, capitalization, punctuation, indentation. Karel is mostly focused on spelling the words correctly and using your indentation to show the logic. Then as you get more advanced and write longer programs, you're going to start looking at what they cost and how efficient they are. You know, we've experienced a lot of that lately. Sometimes things take forever to load because they're not very efficient or they're really large. So we want to bring that cost down so that they work better. And then the next aspect is, once you've written something, how do you test it and how do you debug it? So debugging involves understanding error messages, fixing problems, running it again. And we call those are iterations. So you're doing many attempts with changes in between. This is very important to emphasize to people, not to be afraid to fail. That is really part of the programming life. You do a lot of failing to get something to work. And then finally, you want to make sure that you communicate what you're doing. And when you get up into the third unit of Karel, you're going to start really organizing code and writing comments so that other people, and I put in brackets, including your future self, we've all gone back to things that we've done and I have no idea what that was. So it's almost like we're another person. But organizing it, naming functions with a clear description,
and writing comments.
that's a very important part of programming. Programmers are big sharers. They publish things on GitHub. They share code. They use other people's code. You're working by yourself, but you're connected to every other programmer in the world. And then after you've done it and it looks good, you want to make sure you've met all the objectives. And in Karel, that might be as simple as, did you collect all the objects? It says you're going to collect all the objects in the maze. Did you do it? And Karel's very helpful with that. You're going to get immediate feedback and data on every level you'll solve. You'll be able to see how many operations you took or steps, how long it took to run the program, if you met all the objectives. And then something Dr. Solon has added that wasn't there in earlier years is that after every level, there's a little discussion. So that helps solidify the understanding. So this is a lot of stuff, but it lays it all out. Just reassurance that this is done very gently And then I also made a set of cards that people can print and cut out and sort of monitor their thinking. Because at the end of the day, that's what we want. We want them to learn how to think like a programmer before they start hitting a formal language. This is something that you'll get as a PDF, and you can just print these out or share them as an electronic file with both your adult learners, and if you're running a group, you can do the same. And then I broke down Karel into sort of it's not exactly a cheat sheet. It just gives you a quick overview of what you're going to learn in Unit 1. And basically, you've got the basic commands, how the actions sense objects and obstacles and containers, just like a real robot. So we're emphasizing that robotic behavior. And right from the beginning, you're getting into computational costs. And I'll give you a couple of examples of these in a moment. You're already working on choosing the best solution, you're working on debugging, and then you're learning the first computing structure, which is a repeat loop, which will repeat a set of actions. And then at the very end, a little bit about nested loops, which are repeat loops inside other repeat loops. I do mention that there's a story, and of course it's a fantasy story. Sophia the creator and Karel the robot going in castles and crashing in airplanes and all kinds of fun stuff. Encountering pirates. Obviously, that's a fantasy tale, but a lot of what they're doing are real-world type programming problems. So it's a little bit of context. At the very beginning, Sophia starts by testing Karel's grasp and how Karel responds to voice commands. And those are great research topics that people can run with, even from the very beginning. This just shows people how the sections and levels are laid out, and because a lot of times that's a bit confusing. And also how you can see how many points you've scored and how you earn points, how you can take the levels over and over again, what the quizzes are, what they consist of, and that you can retake it once to improve your score. So you can't take the quizzes over and over again, but you can retake it once if you want to get a better score. And then after that, it's always available for review. So if you want to just read it again to see how you answered it, then it's there. In section 1, you're just moving things with buttons or keystrokes. So the nice thing about that, because you're not writing a script, you can just focus on how Karel behaves. And then in section 2, you go to writing the commands. You can do it in English, Spanish, or Czech. As you probably know, Dr. Solon is Czech, so Karel is used in the Czech Republic. We've attempted to do other languages, but really those are the only 3 that are fully developed. Then in section 3, you get into the repeat loops, and I just put a very simple example. So instead of writing go 6 times, you're writing it as repeat 6 and then indented go. In section 4, you're now starting to work repeat loops into more complex programs. So the point here is that when you analyze a task and you're looking at the maze, you look for patterns that are repeated and you look for steps that are not repeated. So you might have to do something before the repeat loop or after the repeat loop or between repeat loops. And now you're really looking at analyzing how you're going to solve it and what tools you're going to use. And then in section 5, you're writing programs that include more than one repeat loop. And then you're also learning how to write nested loops. So this is an example of a nested loop. Every time there are 3 loops, and then within that loop, Karel's picking up 4 pearls from the oysters. At the end, people earn a certificate. It's quite professional looking, and it'll outline the skills that you've learned. So just a quick peek at what that looks like in the program. I'm just gonna scoot that over so I don't click on it. Okay, so this explains how you can learn in any language. There's a welcome screen. So all these tutorials have several pages, some links to materials. It goes over the course outline and the plan. Then a lot of times a level will have a video that walks you through a procedure. And then we start the storyline, and there's Sophia doing some work on Karel. And this is testing Karel with some voice commands. If you remember the old graphic, it was like a little kid's story. This is much more like an older person working on robotics. Same task, looks a little different. And then it shows you how to use the controls, and then you have your first maze, and you can practice the skills. So level 1 is all manual controls. Get a nice attaboy. And this is what I was saying before, it's giving you the data. So it tells you that you took 10 steps, did 14 operations, how long it took, how many objects you collected, and how many points you earned. So this is all data. And then in section 2, you are now taking the same commands and you're writing them. And there's the story again. We won't go through that right now in the video. And then you can see this time you're actually writing the commands and then stepping through or running the program. This is a demo level, so they're written for you. And so you can see what Karel is doing on each command to see the cause and the effect. Okay, and then section 3, we've got the repeat loop. More story, more video, and then explaining how the repeat loop works, and another demo, and so forth. And that's basically it. Section 4, you can just see, looking at these little pictures here, I'll pull this one up here, that the programs are getting more complex. Here Karel has to get into a starting position, and then this procedure of getting the coin, putting it in the box, and moving to the next point is a pretty complex repeat loop. So by this stage, you're writing programs that have some degree of complexity. And then finally in section 5, again, the programs get more complex. As a librarians, you have instructor privileges, so you can always see the solutions. Your learners will not have that privilege. If you didn't see these before, these are the postcards that we made, and we'll be sending out electronic versions as well. If you have a need for these, Norma and I were just talking before everybody got here, just send me an email how many you would like, if it's something you can use right now. And then she is also going to be sending out some packages, so we'll make sure they're included in those. So just give me a holler if it's something you can make use of. If there's no questions right now, you can always email me later too. I'm going to end this meeting, and that'll give you a chance to go get a coffee, and then we'll start Karel Part 2.